So today we are going to talk about how to solve a system of equations using the elimination method. Elimination. Solve a system of equation using elimination. So far, when we have seen systems of equations, we've solved them by graphing and we've solved by substitution. Graphing, we noticed, was an imperfect way of doing this because if I had a line that was like this and a line that was like this, and I said, what was the solution? There'd be no way of telling exactly where that is, and if that actually fell nicely. I mean, it looks like it's at 2, 1, but actually it's a little lower than 2 and a little higher than 1, and I would never be able to figure that out. So the graphing method is not the most precise method. Substitution seems to work well, except if I gave you equations like 5x plus 7y equals 13, and 3x plus 5y equals 19. Those are not really nice equations, especially to have to solve for a variable and then plug that in. It's going to get really ugly when we get to fractions, when you're dealing with the fractions. And that's just, in general, I'm not even going to deal with this one in a second, but it just doesn't make sense. So we need to come up with a better way of dealing with these equations to solve them. Let's take a look at a very simple. If I gave you x plus y equals 5 and x minus y equals 1. Simple set of equations. I could easily solve either one of those equations for one of the variables and substitute it back in for the other, yes? Yes. Of course I could. But I have a trick, and watch this trick. Instead of doing all that work, I am literally going to take these two equations and I'm going to add them together. Watch what happens. X plus x is 2x. Y plus negative y cancels out equals 5 plus 1, 6. Now I have 2x equals 6. How do I solve that? Divide both sides by 2, and I get x equals 3. Now all I have to do is substitute that back into one of the equations. All right, 3 plus y equals 5. Subtract 3 from both sides, and I get y equals 2. So my answer would be 3, 2. Well, you don't see this in the first place because you have to get to that point and to understand why this is going to work. There's a little bit more to this that you haven't seen yet. So just bear with me. Let's make this simple. You try this one. X plus y equals 5 and 2x minus y equals 4. Let's pause the recording and let you try this. So, if we were to solve this, if you did it right, you would have added the two equations together. You would have gotten 3x equals 9. Divide by 3, and x equals 2. So then I have 2. Oh, no. I was seeing if you were paying attention. I was, and I'm going to stick to that, and I don't care what you say.
Okay,
All
let's
right,
go.
3. So, we have 3 plus y equals 5. Subtract 3 from both sides, and I get y equals 2. So I get the point 3, 2. Yeah, same answer, different equations.
Well,
Now, here is where this gets a little bit tricky. Look at this equation, set of equations. 2x plus 3y equals 8. X plus 3y equals 7. If I was to take these two equations and just add them together, I would get 3x plus 6y equals 15. That didn't help me. Because I want to get rid of a variable. The whole thing is to eliminate a variable. So that doesn't work. Uh-oh, am I back to doing one of the other methods? No, I'm not. Because, watch this. I noticed that the coefficient of y in both equations is 3. But if I took the second equation, I'm going to move this over a little bit. If I leave the first equation the way it is, but I take the second equation and multiply it by -1, I get negative x minus 3y equals -7. Now, when I add these two together, 2x plus negative x is x. The 3y's cancel out. Equals 1.
oh, that was easy.
Now, I just had to plug that in. I go 1 plus 3y equals 7. Subtract 1 from both sides. 3y equals 6. Divide by 3. So y equals 2. So I get 1, 2. So I can multiply an equation by a factor, it doesn't matter what it is, to eliminate one of the variables.
What if the coefficients aren't the same?
What if the coefficients are? What if I have the equation, let's take this one for instance. 2x plus 3y equals 7. And you know it's not going to come up nicely because I'm making this up at the top of my head. And we have, say, 3x plus 4y equals 8. Now, here's an example of where the equations none of the coefficients are the same. So here's what I'll do. Make a decision. Which variable do you want to eliminate? Y. Okay, we want to get rid of y. I want to make sure that the coefficients of y are what? They are going to be additive,
Reciprocal.
not reciprocal, additive,
Opposite.
opposites. What do we call that? That's called the,
Oh, it's a line.
starts with an I, inverse. I want to make sure that the coefficients of y are additive inverses. So what can I do to the equations? Well, here's what I do. I'm going to multiply the first equation by 4. And I'm going to multiply the second equation by -3.
That makes sense. Because they have to be opposite.
I want them to be opposites. So then I get 8x plus 12y equals 28. And -9x minus 12y equals -24. Now, when I add the two equations together, I can't believe this is going to turn out nicely. I get -x equals 4. But I don't want negative x. Multiply by negative 1. And I get x equals negative 4. Okay, now that I know x equals negative 4, I plug it in for y. 2 times negative 4 plus 3y equals 7. That's negative 8 plus 3y equals 7. Okay? Add 8 to both sides. And I get 3y equals 15. Divide by 3, and I get y equals 5. So my answer is negative 4, 5. Now, if I want to make sure I'm correct, take your answer and plug it into the equation I didn't use to find y, which would be the second equation. 3 times negative 4 is what?
Negative 12.
Negative 12. 4 times 5 is what?
20.
Is negative 12 plus 20 equal to 8?
Yes.
Then I know my answer is correct. Okay. Why don't you try this one for me? 3x plus 5y equals 30, and 5x plus 8y equals 49. I want you to try this one, so we'll pause the recording. Okay, so let's see how we did. If you did this correct, I don't want that. If you did this correct, you would have multiplied both by a factor. Now, I could eliminate either the x or the y first. The question is, which one is easier to do? You know, I think in this case the x becomes easier because it's not as big of numbers, but it really doesn't matter. I'm going to multiply this by 5 and this by negative 3. When I do that, I get 15x plus 25y equals 150. Here I get negative 15x minus 24y equals, and now I got to do 49 times negative 3, which is negative 147. Now I can add these two equations together. Oops, that should be an x, and those cancel. And I get y equals 3. Now I have to plug it into an equation, and I'll plug it into the first equation. 3x plus 5 times 3 equals 30. So that gives me 3x plus 15 equals 30. Subtract 15 from both sides. And I get 3x equals 15. Divide by 3. So I get x equals 5. So my answer is 5, 3. How many of you got 5, 3? Any questions on this one? If you didn't, do you see where you made your mistake? Okay. So the question comes down to, the next question we have is, what happens if I have this as my equations? 2x minus 3y equals 8, and y equals 4x minus 7. Can I still do elimination? And the answer is yes, I can. The problem is that in order to use elimination, both equations have to be in standard form. So what I would do is I would take the second equation, and this is again 2x minus 3y equals 8. The second equation, I would subtract 4x from both sides. Because when I do that, I get negative 4x plus y equals negative 7. Still not ready to eliminate. Because I still don't have additive inverses somewhere. So here's an interesting question, because this one really poses an interesting question. Which variable do you want to eliminate?
X.
X?
X.
And how would you eliminate the x?
Multiply the top one by 2.
Multiply the top one by 2. Out of curiosity, could I have also eliminated the y?
Yeah.
By doing what?
1 divided 1 by by 3.
Multiplying the bottom by 3. So it wouldn't have mattered how I did this.
In standard form, isn't A supposed to always be positive?
Yeah.
Okay, yes it is, but in this case, because I'm doing elimination, okay, I need that to stay negative because eventually I'm going to make it negative anyways to be an opposite if I'm eliminating the x. So in this case, it doesn't matter if it's negative because it's going to work to my advantage. If I multiply this by 2, then I end up with 4x minus 6y equals 16, and negative 4x plus y equals negative 7. So it actually worked to my advantage because I just didn't have to multiply something by a negative number to make them opposites. Okay? So that's okay. You're right. If that was going to be my final answer, then absolutely it has to be positive. But because it's within a problem, it doesn't matter. And just to show you, negative 5y equals 9. So y equals negative 9/5. And then I would plug that back in and get what x is, but I'm not going to do that for you right now. That's for you. All right, so I'm going to leave you, and I want you to do this problem and bring it in to class tomorrow. And here's the problem. 2p minus q equals 8, and 1/3 p plus 1/4 q equals 3. This is the problem I am going to leave you with. See you in class.